David Smith here with another Flipped Classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Okay, today's topic, rotations. This is our third transformation. Remember, we started out with translations, which were slides. Then we did reflections, which are reflections across a line. And now we're going to do rotations. And so what a rotation is we're going to do all our rotations around the origin. This makes it a little bit more simple. And we're going to just rotate a point to start with here over an angle theta. So point P starts there. It gets rotated around this point, theta degrees up. That gets us our new point, P prime. So this gives you the feel, the geometric feel for what that might look like. Rotate point P through angle theta about the origin. So that's what this diagram is showing us. A couple things to note. The distance from P to the origin is going to stay the same. In fact, if you just kept rotating around, you're going to have a circle with the radius being the distance from the origin to P, or at any image as it goes around. Standard. This is weird. Positive rotation is counterclockwise. You might think that positive should be clockwise since that's how our clocks go, but that's not how we do it in math. Remember, first quadrant, second quadrant, third quadrant, fourth quadrant. So there is precedent for how we do that. We count the quadrants also counterclockwise. Okay, so if you want a challenge, do the following. Here's that same point, 3, 1, that we reflected in the last lesson. Now we're going to rotate it. I'm going to go ahead, erase this, put up a new table, but if you want to try this before I do that, you can do that. So here are the 3 rotations that we're going to do. We're going to rotate it 90 degrees, 180 degrees, and then also minus 90 degrees. Okay? Okay, so let's rotate our point on the graph so we can figure out what goes there. Now, a 90-degree rotation is going to make a 90-degree angle right there. So what we're going to do is we're going to rotate it over right to there. And what's this new point going to be? -1, +3. -1, 3. So notice how the 3 and the 1 switched and the x term went negative. So what we're going to do is we're going to go yx. So you take the y value, you put it in the x place and you change the sign, and then you take the x value and put it in the y place, which is exactly what we did there. Okay? Now let's do 180, which is just another 90 in the same direction. So it's going to make another 90-degree angle right there, and we're going to rotate. So this one rotated like that. This one's just going to rotate on down to right there. And what's that point going to be? -3, -1. So what happened with our 180? We started with 3, 1, and we ended up with -3, -1. So this one's just -x, -y. So all we do when we're doing a 180-degree rotation is we just change the signs on our x and y. That one's pretty straightforward. Now, to finish this, notice how we're doing -90. We could also do 270, which would just be another 90 degrees around, which would get us down into here. But we can also consider that as a -90. So that's going to make a right angle right there. We're going to come on down like that. There's our point. And what point is that? That one is 1, -3. So now, what did we do? What did we do to x, y? We switched them, and this time we made the y negative. So this becomes y minus x. Okay? So that's our 3 rotations. All other rotations are some version of one of these 3. All of their 90-degree rotations. Think about it. How about a rotation of 360 degrees? What does that do? Nothing. How about a rotation of minus 180 degrees? What does that do? That's the same as this one. Positive 180 gets you to here. minus 180 gets you to there. And so we could do bunches of combinations. Okay, so I've set up an example. We're going to rotate this line, or I'm sorry, yeah, we're going to rotate the line. But before we do that, I just want to finish up this discussion by showing you the translation equations, the transformation equations. So, strictly speaking, you don't need these. You can just see it in here. I think it helps to tease it out, whatever works best for you. But let's take a look. So, what happens to my x? What's my x prime going to be? It's minus y. So x prime is minus y. And the same for my y. What's it going to be? It turns into an x. So y prime is just x. Same thing here. What happens to my x when I rotate 180 degrees? It just goes minus x. So x prime is minus x. Similarly, y prime is negative y. Lastly, under the minus 90 degree rotation, x becomes y. So x prime equals y, and y becomes negative x. So y prime is negative x. So these are the three translation equations that come out of these rotations. Either way is a good access point for doing a problem where you're rotating like an equation or a point. So let's do this. Here is a very similar general form equation of a line. And just to review, remember, the x term has to be positive. So if you're checking your work and your answer is slightly different than what you see in the answer key, take a look. Make sure you've got a positive term for your x. Otherwise, multiply through by -1 and you'll get there. Okay, so what we're doing is we're taking this line and we're going to rotate it 90 degrees. Notice how that's a positive 90? That means we're rotating counterclockwise. Okay, so what are our equations? That's this deal right here. So x prime just equals x, and I'm sorry, x prime equals y, and y prime equals x. I'm sorry, x prime equals negative y. So right off of here and there. So those are our equations. Now we just substitute. Okay, so let's do that substitution. 2x. So what does x become? My new x prime is negative y. So that's 2 times minus y. And I have a minus. And what does my y become? My new y prime is just x. Equals minus 6. Now I have negative 2y minus 3x equals negative 6. Now, general form wants the x term first, and it should be positive. So we're going to rearrange these two and multiply by -1. It's going to change every sign on this equation. 3x plus 2y equals 6. Okay, so let's take a look at the graph of these two equations. But before we do that, pause the video and think for a minute. What should the relationship of these two lines be? What should that look like on our resulting graph? Okay, let's do that. Let's find the x-intercept of this first one. So the x-intercept, when it crosses the x-axis, happens when y equals 0. So when y is 0, this part goes to 0, and you're going to have 2x equals negative 6, or x equals negative 3. Okay, so this line crosses the x-intercept at negative 3, right there. Let's find the y-intercept. The y-intercept happens when x equals 0. So that means that this term goes to 0, and we can solve for y. That's minus 3y equals 6. Divide through by negative 3. You're going to get y, that's minus 6. You're going to get y equals 2. So that one comes here. So let's see how well I can draw this line. Okay, so this is the line 2x minus 3y equals negative 6. All right, so now let's do the intercepts for this line over here. The x-intercept happens when y equals 0. So that is, let's do the x-intercept. So the y term goes to 0, and you get 3x equals 6, which gives us x equals 2. So the x-intercept happens on this line at x equals 2, right there. Let's do the y-intercept. So the y-intercept happens when x equals 0. So this term goes to 0, and you get 2y equals 6, which gives us y equals 3. So that happens at the point y equals 3, right there. Let's draw that line. Not too bad. And this one is that line there. This is 3x plus 2y equals 6. Now, does that look like you would expect it to? Yeah, we've rotated this line 90 degrees. So it should be perpendicular. I think we can be pretty confident that that's a 90-degree angle, but we can check. So let's take a look at the slopes. What is the slope of this line? Remember, slope from general form is just the x coefficient over the y coefficient, change the sign. So the slope here is 2 over 3. So we'll do the same here for this slope. This slope is x coefficient over y coefficient, change the sign. So that's negative 3 over 2. Now, that confirms that these two lines are perpendicular. Pause the video and think that through. Do you know why these two slopes do that for us? Okay, two lines are perpendicular if their slopes are the negative reciprocal of each other. So 2/3, negative reciprocal is flip and change sign, so negative 3/2. So indeed, these two lines are perpendicular. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.